Hello everybody and welcome to another video of Python. Today we're going to be looking at looping. First we're going to start with the while statement, and then from there I want to show you how lists work in Python, at least give you an introduction, and then we can look at those more in detail in the future. And then we're going to go into the for statement, which is another way to loop. And so we'll see how far we get on this, but whatever we don't get done in this video, we'll do in the next one. So last class, to rehash, we were talking about if statements and we kind of got through that. And so now you're able to not just write code that goes from beginning to end in a single path, but to be able to have code that goes from beginning to end through a bunch of different branches and pathways. And you potentially have 100 different endings to your program. But ultimately there is a beginning and there's an end, right? And it's a measurable number of steps. Obviously, the steps vary based on the branches and how big the branches are, but it's still a measurable beginning to end, predictable. That's going to change today, because now we're going to introduce the ability to repeat code. In the past, if you wanted to run some piece of code and then run the same line of code 3 times, like suppose that you have a number, and I said to you, okay, I would like you to multiply this number times itself 3 times. Well, you could be like, well, then I can just do 2 times 3, right? Well, no. If I want to do like an exponent, well, then you can just do, you can actually write one line of code that does that. But that's not the point. There's something more interesting, okay? Let's say that I said, okay, you have a little bar here, and this bar has a 2. And I said, okay, I would like you to write the code that says bar 1 is equal to bar 1 times 2 again, or maybe not 2, but like let's say something harder to do, like whatever that number is, okay? And I said to you, I would like you to do that 3 times. Well, you could just copy and paste the line 3 times. You could also do some math and actually combine all of this. That's doable too. But, I'm just trying to make an example here. Obviously, doing the math way and simplifying this would be ideal, but what you definitely don't want to do is this. You don't want to have to write the same piece of code 3 times. Also, suppose you wanted to do a program that decided how many times this code should run. Like, it might vary between each time the program runs. You don't really have an easy way to do that here unless, again, you use math. So what I want to show you today is how you can create your programs and then make them run repeatedly, and potentially for infinity. Suppose that you wanted to print out on the screen the word hello 100 times. That's a good one, because right now you don't really have a way of doing that. Like, you could just write a really, really, really big if statement that says hello, and then copy and paste this like 100 times. And of course, once you copy it 3 times, you can copy and paste it 3 times again, and maybe 3 times again, and then you can just take all of that and then copy and paste it, so you can copy and paste more efficiently. And then you just keep doing it over and over again. And eventually, I'm not sure how much, but I'm guessing we're about 70 right now. Probably here. Of course, they would have to be all nicely lined up, but you'd get about 100 hellos now. Right? Who wants to do that? Especially if your boss comes back and says, oh, you know what? Like, the hello's cool, but like, can we say hello there instead? And you're like, oh no, I gotta go back and either edit each one of these or completely rewrite this, right? So, or you can just say I quit and then not do anything and be like, I'm done. Nope. Or you could learn how to loop code and then not have to run into situations like this. So, looping, also known as iterative code. And looping or iterative code, the idea is to be able to write a statement in Python and tell Python how many times you want that piece of code to run, and it'll just run it in circles until it finishes or until it sees other ones. As you can see by the topic here, we have two kinds of loops that we're going to be discussing in Python. The first one is a while loop, and the other one is a for loop. Basically, we like to consider one to be a conditional based loop and the other one to be a counter controlled loop. So the first one is going to be the while loop. That one is going to be what is known as a conditional control loop. And like I said, the for loop is going to be a counter control loop, but we'll look at that one later. Okay? I'd like to start with the while loop this time around. So the idea of the while loop is to have a Boolean expression that gets evaluated every time the loop runs. And as long as that expression is evaluating to true, the loop continues. The moment that expression evaluates to false, the loop terminates. So that's why we call it a condition control loop. That conditional statement is what's controlling the loop. The syntax for the loop is actually familiar compared to the if statement in syntax, because in the if statement you have your if, and then you have your condition. This is some sort of conditional. Actually, let's do a different color here. It's kind of hard to see that one. But you have your conditional statement in your while loop. So like, if A is greater than B, or if some variable is true, what you would do, we just put the variable name instead of saying bar equal to true, or if grade is greater than 90, or any of the examples that we've done, right? And then you put your colon, and then you have your space here that you have tab, which has to be consistent, at least within that if statement, in case you have multiple lines in the if statement, and then you have your code that runs. And that is your basic if statement, right? When you have code after the if statement or before the if statement, which we'll just do with gray code, that would be either up here, and that would also be lined up to the if statement. So like right there, this is all lined up. And you can also have code afterwards, right? You don't have to, but I mean, more than likely you will, because this is part of a larger program. But ultimately, you have everything lined up here, right? So that I is lined up to the first character, and so on. You're going to see that the while loop is very, very, very familiar to this. In fact, let's go ahead and put it in side to side. All you got to change here is, let's move this for a second out of the way. So let's put it down here. So all you got to change is this word if. And you can guess what's going to go there. You guessed correctly, it's while. And then bam, you're pretty much good to go. That is it. You have now made a while statement. Congratulations. End the video. Now, but we're definitely getting there. So this here, again, the while has to be lined up. This is now a loop. And in this case, if the while statement evaluates to true, then this is going to loop forever. In fact, if you just want to make the world's simplest loop in Python, oops, my bad. All you got to do to achieve that, what's happening? Skynet is taking over. Okay, is just write a statement that says while true. And then let's go ahead and print something in here. Hello. But by the way, if you remember last time when I was talking about the pass statement, you could also do that in Python. You could just you could write in there a pass, just because you do need to have something in your while loop. Just like in the if statement, you need to have something that's tabbed in. So you need to have something here on the blue, at least one statement. And if you have nothing and you want to put a placeholder, you can use the word pass. Okay, but for now, we're going to actually put something like hello, because that's what we're trying to achieve, right? So here you go, the world's simplest loop. It's a loop, but the way it's going to run is it's going to run the code above it, And when it hits a loop, it's going to check the condition here, right here, which right now is just true. So true is true. So yes, the condition passes. So that means go into the loop. So it runs into the loop and it starts running this loop. And when it finishes this, you know, let's say that we have a code down here that says like end of loop. And there's a print statement here that says start, or not actually technically before loop. Okay, so when the code is running, we'll see the before loop get printed out as we hit this line. We're going to enter the while loop. It's going to evaluate the conditional expression, which is just true. So true is true. It's all, you know, if you want to, it's the same thing with an if statement. If you run an if statement that says if true, that's just going to run forever. So you might as well not even put the if statement, right? But yeah, but here it's going to matter because when we hit while true, it's going to enter the loop. It's going to run the loop code. So it's going to run this line of code, or if it's multiple lines, it's going to run them in order. Actually, this one. And when it finishes the last line of the code, rather than printing the end of the loop, it's going to go back to the beginning. So the control, like literally, if you think about the line, the little dot as my debugger dot that shows which line you're running, when it gets to the bottom of the loop, it's going to go back to the top. And it's going to check the condition again. And if the condition is still true, it's going to go back in the loop. And going to run the loop again. Bam, 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 bam. Finish. Go back to the top. Check condition. Condition still true? Keep going. And because this is always true and this never changes, this is going to run forever. Just non-stop. You can leave your computer on all day, all night. It's going to keep running hello. It's definitely going to do more than 100, I tell you that. So, that's cool. But, you know, if you go into like, you watch a trailer like The Matrix or something, they say like everything that has a beginning has an end, Neo, right? So in our case, that's not very true because we don't have an end. It's just going to run forever. You will never get this end of loop printed. So loops are great because they allow you to run code, but they're also dangerous because they allow you to run code forever if you're not careful. So there's something that you want to do. What is the name of this? It's called a conditional control loop. This condition is what controls whether this is going to keep looping or not. So what you want to do when you're doing a conditional based loop is you should have some code in here that is going to modify that condition. And you want to, at some point when something happens, which is a sign that you want to stop looping, you want to set that condition to false so that the loop stops. So how do we modify this to change that? Well, first of all, we don't want to hard code any values here, especially the while condition loop value. So let's go ahead and just write a variable called con for condition. And at the beginning, we're going to set it to true because we do want the loop to start. If the condition is false, it'll be the same thing as an if statement. It'll look at false and then skip it. With the if statement, you know, if it looks at the condition and it's false, then it just goes straight to this code and just moves on with its life. Here, the same thing would happen. If the condition is false, then it's just going to skip the loop and go to the end of the loop immediately. But then why have the loop in the first place, right? Well, maybe sometimes you don't want to run it. Okay, fair enough. But in our case, we do want to run it because we do want to print it hello 100 times, right? And so here, what you will write is your condition. That's going to be the comparison. But you can write anything you want in there. Anything you put in the if statement, you can put in there basically. However, what you want to do in here is you want to put some code that actually stops the loop at some point. So in our case, you know, we could put an if statement that says like, actually first, let's go ahead and increase condition. Actually, condition is a Boolean. So here, for now, let's just set it to false. So I can show you how that will happen. Okay, so let's just say that like the first time the loop runs, we set the condition to false. What's going to happen now is it's going to go into the loop. It's going to run this line of code. It's going to be like, okay, cool. This is false. Print hello. Go back to the top of the loop. My phone thought I said hello or something. I don't know. And then see the condition again, and then see that it's false, and then it's going to jump out. So now we went from like loop to what is basically a glorified if statement. Okay, but at least we know how to exit loops. Now we want to exit at a specific amount. Let's actually change this to be a number. And let's make this be 100. So now let's make our condition be while the condition is greater than 0. Which of course 100 is greater than 0. And here, let's change the condition value to be the condition value that it currently has minus 1. So now, when the code starts, we get 100 greater than 0. But then immediately after, when it starts entering the loop, we get 100 minus 1, which is 99. Goes and prints hello, goes back to the top. 99 is still greater than 0, so we go back in the loop. Now we get 99 minus 1 is 98. Prints hello, goes back to the top. 97, 96, 95, 94. Eventually, when it gets to 0, 0 is not greater than 0, so it's going to jump out. And now we have achieved it. But technically, this is using a counter. So a for loop would be more beneficial for this. However, you know, it's good to understand a while loop either way. Let's go ahead and just code this really fast so we can prove that this is actually functional. So there's a code up here. Let's just write that in and see if it works the way that I claim that it works. Okay, and then print our hello, and then go ahead and print end of loop. And let's use our debugger so that we can kind of see what's happening. So let's just put a debugger right here and just run the code. All right, we get a before loop printed, and we can see that the condition is going to be set. So let's actually do a variable watch here and see the variable. So it's a global, actually, I think. Here, let's oh, let me run that one more line. Here we go. Okay. Add to watch. Okay. So what was happening was that I ran this code. I hadn't actually run this line, so Python hadn't created that variable yet, and so that's why I couldn't find it. But I had to run the line that says 100. So now we have a condition and it has 100 in it, as you can see there by the variable watch. Okay. And so it's going to check the comparison if 100 is greater than 0, and it's going to say yes, it is. So it enters the while loop, and then as it runs that line, it's going to decrease it to 99, as you can see there. And it's going to print our first hello. It's going to go to the top. It's going to check that it's indeed true still, because 99 is greater than 0. It's going to go back to the counter there. That's going to decrease it. 98. Print hello again. So top. I can do this all day. You can see every single time it's going down. At some point, it's going to get to 0, but I don't want to wait too long, so I'm going to switch this from 100 to just 10. There we go. We got our 10. So from there, it's 9, 8. Oops, sorry, I hit continue or something. Okay, so we got 9, 8, 7, 6, 5, 4, 3, and let's slow down. So we got a 2 greater than 0, so that's still true. Then we're going to do 2 minus 1 is 1, so then we store 1 there. We print another hello. We get 1 is greater than 0, which is still true. 1 minus 1 is 0, so condition that has a 0 on it. We go to the top of the loop, and now we're checking whether 0 is greater than 0. 0 is not greater than 0 because they're equal. So bam, it gets out of the loop, prints out that end of loop, which you can't quite see. Ah, I see. It's because The other version is better because I realized that was it. They're like zooming at different levels. This one and the one where I have the iPad showing. So that is why that is kind of cutting it off. But we don't need to see the code anymore because we wrote it. So let's just switch over to this one so we can see it. Okay. But yeah, as you can see, we have the variable watch there, which is very nice. If you ever want to be able to do that under locals or any variable you want, you can right click on that in VS Code and click add to watch, and that's how I got this here. Okay, but yeah, that's how your loop works. Now again, this is really just a counter, so the for loop is actually easier for this, but you know, most of the time whenever you want to write a loop that just runs until something happens, you will use a while loop, but you can still use it for a counter if you really want to. So what are other usages of a while loop that are condition based? Well, for example, when you're reading in a file. So suppose that we were opening a file from somebody and we wanted to read in all of the text from that file. We don't know how big that text is, so we can't use a counter for that. The file might have 10 words, but it might also have 100 words. If we put a counter that says read 10 words and the file has 100, it's not going to read them. If we put to read 100 words and it only has 10, what are you going to do after the 10? Like, it's going to keep going and it's going to read the same last word, or it's going to crash, or bad things are going to happen. So there isn't a nice and clean way with a counter to do that. Whereas with a while loop, you can just have the loop react to the situation at hand and actually terminate whenever it needs to terminate by just changing the condition. Of course, there is a way to terminate a counter-based for loop ahead of time by using the break command. So I will show you break and continue probably at some point, but not today because we're just trying to get the basics down. So, having said that, let us try and try to do this with a file. So actually, in the same directory, I got code from other examples that we've done in this class. So why don't we actually just open up one of these other files by taking our assignment 3 code and throw that in the loop. So let's make a new one. Let's call this one 09.py. Copy the second one that we did, the file.io example that we did some time ago. And we're going to use that one, except we're going to open up, let's just open up actually 08. Yeah, let's open up 08.py. So we're going to read from there. We're in read mode. And we are going to read the file. Now, yes, there is this read line program to be able to read and all these things, but what I want to do is I want to read each word and count them. That's what I want to do with the file, okay? That's one of the powers of a loop. So our program is going to be called word counter. And we know that we can use this with open thing. So what I'm going to do is I am going to use the read, that function that I was doing. So I'm going to say f.read and let's just print that out first so we can see what that does. Just one f.read. I think that's actually going to read the entire, well, here, let's see it. Okay, yeah, so it's going to read the entire file, and then it's going to terminate. It printed the true because of this, but yeah, it's going to terminate, okay? So what I'm doing is this function is going to read the entire file into whatever variable we stored on, and so then we can proceed to do counting on it, okay? So all I got to do to this is I'm going to make a variable, and I'm going to call that variable content, or f content, for file content, okay? For now, I'm just going to basically, We can just do it in here directly. Try not to get ahead of myself, and because I haven't shown you lists yet. So let's just do that, and let's see if it's accessible. So, yep, it's accessible. Okay. So what I'm doing is I am reading all the content into here, and there is a function in Python which I believe I showed at some point that tells you what the type of a variable is. You just call it type. And you put it in parentheses. So similar how you do the casting to an integer by saying int in parentheses, but here it's type. If I run that, it tells me that it is a string, which is what I want, because I don't want to do lists yet, because I'm showing you a list, okay? So what it's doing right now, what this piece of code is doing, is it's reading in this file, which is this one, is literally the code that we just wrote, is reading in that file into a single really, really big string. That string contains line feeds and other things. I'm pretty sure I showed you, but just so you remember, a line feed is stored as a \n. So if you say like hello world like this, it'll actually put it on its own line. Well, I need to print it out so it does something interesting. But you can see it printed on its own line, okay? So line feeds are stored that way. Spaces are just stored with spaces and so on. Okay? Tabs and things like that have special things like, I believe tab is \t. So if I do this, you can see a tab there, which is more than one space. Okay? So now that we have seen that this is a string, I would like to tokenize a string by reading, counting the number of words. And I can do that with a while loop. Could also probably do it with a for loop, but again, we're going to just go with a while loop, okay? So let us go ahead and write our condition for the loop, which is just going to be while not done. Okay? And for now, we're going to say not done is equal to true. And so now I am going to go ahead and create a counter also. So I'm going to call it wCount or word count. And I'm going to start that at 0. And now I'm going to go ahead and say, see, there's so many ways of doing this that is like more advanced and easier, but I'm trying to simplify this. We need to split the, how do we do this easily? I have to show you what the list is to show you that. Okay. Well, we can say something like fcontent.split returns a list of words in the string. Yeah, okay. So there's going to be some magic happening behind the scenes here. But we're going to say, in fact, let me just double check that this is doing what I'm thinking it's doing. Yeah, okay. Yep. Well, all right. So what I'm going to be doing to get this working with a loop is I'm going to actually split out the strings. So the strings right now are just one big blob of text. But what I would like to do is I'm going to take those strings and I'm going to say, okay, every time you see a space in the program, I want you to consider that to be a separate word. Okay, obviously this is code and not actually English. So, here's a space, here's a space, here's a space. So this is going to be one word. This whole thing's going to be one word. This will be one word. And also this will be one word. So it's going to look a little weird, but it's okay. I'll explain furthermore about what the data type is of this tokens, which is a list actually. But once you split it like that, then you can actually do your while loop and say while not done. You can go ahead and say tokens which of course, once you do this, you could just do length. But yeah, you can say something like tokens dot, or actually use indexing for this, and use your word count for that. I really don't like this example anymore because it requires a lot of other things. So let us actually withhold that example for now and come back to it with a for loop, which is literally what this is screaming to me. Like, please use a for loop for me. Okay? Which I agree, we should use for loop and lists so that we can do this in like one line of code. But here, just because I don't want to leave you hanging, if you really wanted to know what the length of this was, you could literally just use tokens.length. Or sorry, length token. Or size, is it? I can't remember. No attribute length size. Then there must be length. Yeah, there we go. So 20. Okay, so that's literally what you would do actually, and you could have also done that probably with the with that it's fine. Okay. Yeah, we'll come back to this example with a for loop because it does not really like itself being a while loop, and I have to do indexing for this with lists, and we haven't talked about lists yet. So yeah, before I do talk about lists and for loops, let's just think about other while loop examples that might be easier to do. So I have one. So we'll come back to, like I said, to that example. But for now, let me make another line that's a little bit better of an example. Okay. So for this one, what I'm going to do is I'm going to make my entire program be a while loop, but I want to sort of say exit condition set to false initially, and well, exit condition here is basically not true. Or actually, so I can simplify the logic here, I'm just going to call this keep going and set it to true. That way I can set it to false. Now I don't have to use a not. Okay? So what I'm going to do in this program is I'm going to take a value from the user. This is much, much nicer and much more proper usage of while. And say enter a letter. And this is a little guessing game. So I'm going to basically say print welcome to a guessing game. So every time that the game runs, it's going to randomly pick a letter from the alphabet. Actually, alphabet's too big for us. Let's do number. It's going to pick a number from 1 to 10. And then it's going to remember that number. And so you're going to try to guess it. And if you guess it, the game ends and you win. If you don't guess it, then it just keeps going. Okay? So yeah, I like that. This is a much cleaner example. So for that though, I do have to show you how to use random number. So there's a lot of ways that you do randoms, and when we talk about NumPy and other things, we can talk about those. But for now, let us just use rand. See if rand int is in here. We have to import probably random. So for now, I haven't quite talked about how the imports work, but basically you can import other people's libraries by calling import, as the name implies. So in this case, I'm importing a library that allows me to create to generate a random number. Okay, so don't worry too much about that yet. But what I'm going to do is I am going to say the answer value is going to be assigned to be a random integer from 0 to, let's do 6 for now, okay? Just because I don't want to have to sit here guessing all day. Enter a number between 0 and 6, okay? And so now, just so you can see that this is working, let's actually comment out the while loop and just print out this, print answer. Okay, let's see this running. So the first time you can see that it actually put a 0 there. If I run it again though, it has a 5. If I run it again, it has a 3. And if I run it again, it has a 2. This is not a cryptographically secure random number generator, but you know, it's probably using the Linux time and then doing some fancy math on it. But for our purposes, which is just a simple game, it's good enough. As you can see, every time it's different. Of course, it's only a couple of variations it can be, but you know, I could make this really big. But again, you know, so we want to make this feasible. Okay, so now that we know that the random number generator is still working, we want to hide the answer though from the user. In fact, not even I'm going to know it. And then now I have this thing that says while keep going. So now every time it runs, it's going to ask the user to enter a number between 0 and 6. Again, because this is a string, we want to convert it to an integer, so we can put parentheses around that and the word int. And so now we can compare it to an answer. But we can actually do that in the in the loop. We don't even need to do this boolean. But for now, we're going to do it in here, and then I'll show you how to simplify it. So we're going to put an if statement that says that if the number that the user guesses is equal to the answer, we're going to finish out of this loop, which again, I haven't shown you breakout, but you can use breakout. But for now, we're just going to set keep going to false because we won. In fact, we also want to say, congratulations, you guessed correctly. Okay? We could even do a counter that tells the user how many guesses they did before they failed, but for now, I think this is good enough. Okay? So if we run our game, it says, welcome to the guessing game. Enter a number between 0 and 6. I like having a space there. So, you know, let me rerun it again. Okay. So, I don't know. But let's see if today's my lucky day, which, based on the last example, is not very lucky, but let's try. I'm going to go with the safe number and say something like 3. Let's see if I'm right. And I don't know this, so we'll see. Is it my lucky day? No, it's not a lucky day. It's not 3. All right, let's see how unlucky I get here. All right, it's not 3. I want to try 2 now. It wasn't 2 either. All right, I mistyped 1 earlier, so maybe 1 that was assigned to use 1. Wow, it's not 1 either. That's very sad, actually. Okay, well, statistically, now I'm getting to the point where I really should win. So let's try 0. Wow, it's not 0 either. That's very toxic. Okay, I'm really down to the last 3 choices here. So let's just try 4. And there we go. Okay, so like statistics are starting to go on my side. Like, okay, after getting that many wrong, you know, like, gotta get better chances here. So there we go. I don't feel very congratulated after having guessed pretty much every other number, but okay. Let's try again. It's like a casino. You want to try again and see if you get a better chance. All right, this time I'm gonna go ahead and guess a 5. All right, no, 4, 3, 2, 1. Okay, those are not very good odds, but there we go. Let's keep going. It's one last time. Let's see if I can hit it the first time. There we go. I got it the first time this time. Okay, so I'm gonna quit while I'm ahead here. Although I'm not sure if I'm ahead after losing that many. But yeah, okay. So the game works, and this is actually really good usage of the condition-based loop, because the game's gonna run a non-determined number of iterations based on user input. So this is good at while loop. Screw the other example. Okay. Now though, you can make this a lot cleaner. You can start by getting rid of this if statement and just taking this comparison and throwing it up here. If you do that, you don't need the if statement, you don't need the keep going variable, and you can just put your congratulations after the loop since it's going to run anyways, because otherwise they would never hit it. The only other thing you gotta do here to make sure this works is you have to create this bar variable, and you gotta make sure that you don't happen to somehow set it to the same thing as the answer. So for that to be safe, I can set it to like an invalid value, like -1, or I could set it to answer -1, so that way it's never the same value. Doesn't matter. I actually think that the answer -1 approach is better, because if I ever change the range of numbers that this can be, well, if I do that, I gotta make sure I do it afterwards. Then you know, if like in the future I want to allow my game to have negative numbers, then that becomes an issue. Whereas if this guarantees to me that it will always like not ever be the same. Okay, so you know, just to prove to you that it's still going, we have screwed up something. How did we guess correctly? Bar gets answer -1. Okay. What did I do to break this? Well, bar is equal to answer, but they're not equal because I'm subtracting 1 from that. That's weird. Let's try that. Well, bar is equal to. I'm not sure what is happening. Let's use the debugger. Okay. Answer has a 1 and bar has a -1 on it. They're definitely not equal. So when I say while bar is equal to answer, they're not equal. Oh, well, that's why. I'm saying that the game should keep going when they're equal, when what I really meant to say is, because I copied and pasted, that's why you don't copy and paste. But what I'm really trying to say is that the game should not keep going if they're equal, and should keep going if they're equal. So I gotta flip the logic here to say not equals. So while the guess, and let's change this to guess because I think it's a little bit more self-documenting. If we call the guess from the player the guess. Well, the guess and the answer are not the same. Keep asking for a question. But if they are equal, then, you know, that's when you stop. So, yeah, logic. Okay. So let's turn off the debugger. In fact, by the way, the debugger is a way to actually kind of cheat and see what the answer is. So let's leave it on. So turns out that the answer is going to be 6 this time. Oh, cool. We hadn't seen 6 yet. I was beginning to wonder if 6 would ever come up. And then, of course, the guess has a 5 on it, because that way it's not something valid. And so now it's going to ask for a number. So, of course, I know what the answer is now, but let's just say that I pick a 0. It goes back here, and it compares 0 and 6. Because they're not equal, then it goes back and it asks me a second time. So let's put another wrong guess. Let's put a 4. This feels so much nicer knowing what the answer is. So it looks at a 4. It guesses. It says that they're not equal, so it goes back in. All right, let's put in the right number now. Let's put in the 6. All right, press enter. And so now it compares 6 and 6 because they are equal. That means that this not equals is going to evaluate to false, to true, sorry, to false. So guess and answer not equal. So that is indeed a false statement because they are equal. So then that's going to jump out. It's going to print out the congratulations, and then the game is going to end. So there you go. Much better example of a while statement, okay? However, I would say that in Python, the majority of the time, you are going to be using a for loop. So before I go back and revisit this example, I would like to show you how to use lists in Python. So yeah, let's just go ahead and do that. Because range-based for loops, yeah, I could do a range-based for loop, but really the power of for loops and looping in general kind of needs to have lists as a data structure. So let's go ahead and do that. So lists in Python. Okay, so far you have learned of different data types that you've been using. You've been using integers that can hold positive or negative whole numbers, including 0. You've also played around possibly with floats, which are IEEE floating value numbers that can basically hold a decimal really big or really small compared to an integer, but not inclusively of every single number, right? Because I mean, there's an infinite number of numbers between 0 and 1 alone, right? You could have like 0.001, 0.00001, and so on. So there's a limitation to the accuracy and how many numbers you can keep because of that kind of thing. But still, floats can keep a bigger range of numbers, which is very cool. So when it comes to to keeping data with, at least numerically, you have chosen to use an integer or a float, but they keep only one value. On the other hand, when you're dealing with something like a string, that is keeping a set of values, and it's keeping a lot of them. So technically speaking, you could use a string to keep a list of numbers if you really wanted to, but it's kind of nasty and messy and no easy way that you know so far to separate them. Although you could use that split function that I was hinting at with the messed up example. So what happens when you want to keep, especially with data analytics being the name of the game here, what if you want to keep a list of data, or you want to keep a lot of the same type of data to process? So for example, you have 100 different samples that you want to add together, or that you want to do the average of, things like that. In this case, you could write 100 different lines to add all the lines together, or one massive line that adds all of them together. You could also just make a list and then use looping power to be able to iterate to the list and count everything together and get you the average. Of course, if you're really, really good, then you don't have to use any of that, and you just call a library that does the average for you. But that's not always the case. So it turns out that in Python, using lists is really, really easy and very convenient. A lot of programming languages like C++ and Java, you have to specify when you create a list of things, you call it an array, and you have to specify what the type of the individual elements of the list are. So for example, if you're making a list of numbers and those numbers are integers, you have to say that your list is made up of integers. So you say, I'm making an integer array. That's cool, but you're limited unless you do some nasty stuff, which you can. You're limited to storing only integers. You want to make a list of words, you make a list of strings. You make a list of floats, you make a list of floats. But what if you want to make a list of both floats, strings together? In Java and C++, like I said, you have to do some pointer stuff, and it's never going to be really clean, and it's not really the way to go. Or you have to use polymorphism and like make a base class and inherit and all these fancy things to achieve something really basic. The reason being is because you're really if you're trying to do a list that has mixed things in it, so we call a list that has everything the same to be a homogeneous list, and a list that has mixed things in it to be a heterogeneous list. So if you want trying to do a heterogeneous list, the questions can be raised as to why you're trying to do that, because it kind of makes processing it harder because you don't know what kind of data you're going to see. Whereas when the list is homogeneous, you don't have to worry about that. You're like, okay, this list is a list of integers, then I know that they're all integers and I can handle that accordingly. But if the list is literally going to be like a surprise, where like I'm going to take a number out of the list, and it might be a number, but it might also be the word potato, then that's not very convenient. So flexibility comes with risk associated. So whereas languages like C++, C, and Java went the safe route, Python went the it's okay. We trust you not to do bad things approach, which is great. So that's its greatest advantage is also its greatest risk. So just kind of wanted to start out by saying that. So to create a list in Python is extremely easy. All you gotta do is make a variable name. So choose an identifier just like you would with anything else. So I'm just gonna call this colors. I'm gonna make a list of colors. Make your assignment operator and then just go to town making the list by putting hard brackets. So if you just make a list like that, you have now made an empty list. So this is an empty list. If you want to create the list and at the same time initialize it, so we're gonna, comment this line out per se, make another colors list, and this time say I want to put some colors in there. You can, and the trick to doing that is that you comma separate the members of your list. So every time that you add a member, whether it's a string, float, or double, you separate them with commas. You don't need to put space between them, like I did, but you want to separate them with comma. Separate. Okay? As long as you do that, then you are good to go. In the case of a string, you have to use quotes to separate the strings, whether it's single quotes or double quotes. Either one will work fine, but you still got to comma separate them. If you want to make a list of numbers, let's just say birthday list or something, then you can do 1, 2, 3, 21, 5, whatever number it is. And at the end, don't end with a comma, end with an actual value, and then your bracket. Spacing doesn't really matter. Like I said, you can, I think it's a good thing to put a comma, put one space, and then put another value, put a comma. Don't put a comma, don't put a space after the value, just put a comma afterwards, and so on, because it looks nicer and cleaner. But in theory, you could put a bunch of space here, and the interpreter won't care too much, really. As long as things are in the brackets, it's pretty flexible. Same goes if you make a really long list, you can always split it like that, and then it won't care about the spacing here, which can be a good or bad thing because it can confuse you. But you still got to the next line of code, line up with that. But so if I have another line of code that has a var gets 1 or something, it still has to line up there, but here you have this power to kind of go everywhere. And same thing with parentheses. But I would say it's good practice to kind of line it up with the beginning of the list like that. So like an imaginary thing right here is kind of what you want to do. So these are homogeneous, but let's just make a heterogeneous one. So let's say it's a list of, let's call it just data. It might have the word red in it, but it might also have 22.5 like that. Might have a single character. It could have a number, another string. It's not even a color anymore. I don't know what I'm trying to do. Blue. 22.1, and you could even, though this gets a little more advanced, you could even throw in another list instead of a list, like list inception, like that. But we're not doing that yet. We're not there yet. Whenever you're done, just put your closing bracket. So these are all lists, and they're great for storing data. Like I said, very nice, very convenient. This one's a little harder to work with because you don't know the ordering potentially of the data, but these are of course very clean because you know the type. This is of course if you're hard coding it, but there are other ways to insert data into a list. The most important one that you should know at the beginning is the append method. So you're going to write the name of your list here. So suppose that you have the data one. So say you want to insert one more thing to data. So you say data, then you put your dot, and then you say append. And then inside the parentheses here, the syntax might look a little bit strange at the beginning because we haven't talked about functions, but think about like the int conversion thing. So like the int conversion that we were using, it's kind of like that. And then as for this dot, we haven't again talked much about this, but what this dot is doing is called the member access operator. And when we talk about classes, we'll talk about that. But really, in simple terms, the list data type is an object, and objects have different operations you can do on them. And other coders that have created these objects gave it different operations. Things like being able to get the size of the object, being able to get specific different things that it might have. And some of the things that you might want to be able to do to this list are be able to insert things, remove things, sort things, etc., etc. And so whenever you want to access the different sort of features you have, use this dot to be able to reference them. And in Python, it'll do like when you press the dot, it'll do a little pull-down menu, which you can then actually see and see what's available for you to use, basically. So let's make a file, and just to show you really fast, let me go ahead and write data, and let's just put some stuff in here. Actually, let's just leave it empty. Let's start with an empty one. Okay, so if I do data and I press dot, because this line of code creates an empty list, it knows that data is a list type. Because I mean, if I just say like bar and 45, it knows that bar is like an integer. So it would give me the things that an integer can do, which I guess in this case is checking what is real. Let's see. Is that a function? It must be doing some conversion to like a number. Who knows? 2 bytes. There's some weird things that this can do. Numerator, denominator. Don't really know what those are, to be honest with you. The denominator of a rational number in the lowest terms. Yeah, okay. Let's do a string. So bar has the word hello in it. So now it knows it's a string. So if I do the dot, this is more interesting because it has a lot of things you can do with strings. And it tells you the description to the left, what it does. I know it's cut off a little bit there. But for example, these are really cool. It's alpha. So returns true if the string is an alphabetic string, false otherwise. A string is alphabetic if all characters in the string are alphabetic and if there's at least one character in the string. So this is cool. You can run this to make sure that there is only like letters, there's no numbers or weird symbols. The alnum is actually really cool because it does both checking for numbers and digits. But if you go to is digit, this one returns true if the string is a digit string, false otherwise. What is a digit string? A string is a digit string if all characters in the string are digits and there's at least one character in the string, meaning it's not empty. This is the one that we would want to do for the percent. So like in our code where we were checking whether something, with the grading that the user enters like a 45 or 100% for a grade, we can call this function is digit on the string that contains what the user enters. And if that string happens to have a percentage in it, then this is digit function will return false. So then we can give an error to the user to re-enter without a percentage, or we can call our looping to be able to clean it up, which we will do later on next week. But yeah, so these are all different sort of functions or features that you have available to you on a type. And for a list data type, it's no different. You have a lot of things. You have things like appending, count to count how many items there are in the list, copy for duplication purposes, insertion to insert a specific spot, to remove things, to sort them, like organize them alphabetically or rising or descending order, etc., etc. So there's a lot of different features. So that's all object-oriented programming, which we haven't talked about, but that doesn't mean you can't start using those if you want to. But for now, the ones that we kind of need to know for the list is the append method. So the append method is going to allow you to insert things into your list. And so you can see there that it even tells me, append object to the end of the list. And yes, that is true. This is going to insert that item at the end of the list, right? Because that's the thing. If we have a list of values and we're inserting something, you might be thinking in your head, okay, when I say insert, it's going to throw it in the beginning of the list. So like here, other people might be thinking it's going to go at the end of the list. I don't think anybody was thinking it's just going to go like flat out in the middle. But, maybe if somebody did, the point is that we need to clarify that append is going to throw it at the end of the list every single time. If you want to insert somewhere else, like at the beginning or in a specific index or spot of the list, there is a function for that as well, which is that insert function. But for now, the most basic one is the append, which is just to dump it at the end of the list. And so let us achieve that. So let us go ahead and do append and throw in there like a 22. And let's do it a couple of more times. This time, okay, well, we can just do 22s, but then let's do like the word red, and then the word hello, and then maybe like a floating point value, like 0.6, and then like a single letter. Okay, so there we go. And so now, if we want to print out the content of our list, you can actually just call print on it and just pass in the name of the list. It's not going to be beautiful, but it'll show you. Let me just show you what that looks like. As you can see, it printed out with the brackets, kind of how you would see it if you were initializing it yourselves. This is literally the same thing as we were doing here. And it uses a single quote to separate the members for things that are strings. For things that are actually numbers, it doesn't need to put those, as you can see, which is pretty cool. Okay, so what if I want to access a specific member of that list? So like, what if I just want to print out the number 22? Well, that's two of them, but let's say I want to print out the word red. How do I access that one? Well, to access specific indices of your list, you can use the following format. So write the name of your list. So in this case, it's going to be data. And then the brackets that you would use to create your list, you're going to use those in a different context here. You are going to write them like this. And then in here, you're going to write the index of the item that you're interested in looking for. Now, right now, we have the following list. We have 22, we have red, we have hello, we have 21.56, and we have A. And then because red and hello are strings, they are under the quotations, and so is the A. Now, you may have noticed that I'm trying to access red, but I wrote a 2 there. This is something that for non-programmers, it might throw you off the first time you see this. It turns out that the indexing that we are used to as a non-programmer is to say that the first element is, of course, the first element. And the second one is 2, 3, 4, 5, and 6. This is what we're used to because this is what we use in everyday life. When you say, I would like the first item of something, it means like literally the first item. Some programming languages do use this indexing system. But the majority of the modern ones do not use this indexing system, except for like MATLAB. MATLAB will use this indexing system. But Python, C++, Java, and C# do not use this. It turns out that they actually consider the first element of the list to be index 0. So you shift everything by 1, and you put that as a 0. So now you can see why I put a 2 there, because it turns out that the red is actually index 2. It's the third item of the list, but it's the second index that is found. Well, index 2, not second, because that's a misleading term. But you can see how this can be something that's a little bit trippy if you've never coded before, which is fine. It takes some time to get used to. You probably make mistakes with it. That's fine. That also means that the last item of this list is going to be data 5. So if I want to access that, I will put that. However, the size of this list is 6. Okay? If you're trying to kind of think of an easy way to remember this, I think most of us here, well, actually, no, that's true. We have people from all over the world in this class. But think about like European system for floors. In America, when you go to a building, you have the first floor, like the parking garage at UNLV. We have floor 1, right? So like, where the cars are coming in. So like that's the first floor right there. There's a little car driving in. This is floor 1. Then the floor above that is floor 2, 3, 4, and I think we have 5, right? At the top. Let's put a little rail so they don't fly off the edge there. Okay? That's your Cottage Grove parking lot. In Europe, though, I think in Europe, it's been a while, but I seem to recall at least the UK doing this. They don't typically call the second floor the second floor. They usually say something like, you know, like ground or lobby. And then they actually call the first floor what we would consider in the US the second floor, right? They do that. In fact, in some elevators, you'll even see a floor 0 like that for the ground. And so that is kind of how the C++ or Python is working, you know, that we have these sort of floor 1 is actually what we would consider the second floor. And then the ground or lobby is actually floor 0 if you add it as a number. So yeah, just think of that European sort of vibes for the arrays or lists in Python. Okay, so like I said, it's just something you get used to, and you might make mistakes at first if you've never done this before, but with time it'll make sense. And frankly, for someone, you know, when you code for a long time, this stuff is like second nature, to the point that like when I go to MATLAB, which actually uses the indexing starting to 1, like that just throws me off and I make mistakes, which is how you will feel right now. But you get used to it, and it works. Like it's not just done because like, you know, people wanted to spell color with a U instead of without a U. No, it's not like some like Europe versus US or thing. It's because like it just makes logic a lot easier in the long term when you're dealing with indexing. So just to kind of trust me on this. This is good for you. It's good for you. Eat it. Okay? So yeah. So let's just kind of prove to you that I'm not lying about that. So, you know, while data will print out all the elements of the list, if I go ahead and say print data index 2, then I get right out of that. And I don't get it with the quotations either, which is nice. Okay? So I believe, though, there is one more way that I'm going to show you. See, I think it's index, returns the first index of value. Let's try that. I think that one will, yeah, no, it doesn't like that one. I forgot what index does, this function index. Let's read it what it says again. Returns first index of value. Nah, something else, unrelated. Thought there was another way to easily access things, but maybe I'm thinking something else, different language. But yeah, anyways, the square brackets is probably the easiest and cleanest way to do it, okay? So now that we know how the indexing works, we could actually go back to this example and at least finish it with a while loop, okay? So that, and then we can still improve it with a for loop. But going back to the example with the word counter, we actually have a massive string, and when we took that string and used the split function, it actually made a list out of the string and using a space to split it. So this is actually a list. So when I say print tokens here, I'm getting the word print. Oh, because that's part of the code. You can see this is the beginning square bracket and this is the end square bracket, and you can see all of the elements of the list now. So like if I want to print out the index 3 of that, oh, tokens plural, my bad. It's actually the equal sign, because we have this whole thing is the first one, second one, third, well, technically see index 0, index 1, index 2, and index 3, which is actually the equal sign. So now you could actually use a while loop to iterate through here by saying something like while, you know, gotta get the length of it and then go through it each time. Or you can say you know, until we hit the last word. So for now, let's just use this last word as a flag that we're done, since we don't know the length, although we can use the length function. So we can say while token sub I is not equal to this weird string right here, then we will keep going. We can just say print tokens sub I. I'm so used to putting these because of it's a C++ class. So, yeah. So now, you know, we can make a counter I. Oh, we were using W count. W count, and then we want to make sure that we increase it. So W count plus equals 1, which is the same thing as saying W count equals W count plus 1. And then if we do that, we are getting an error somewhere. Oh, it doesn't like this here, so let me just put a backslash. Actually, no, the backslash should be here. See, there's a quote here, so we gotta make sure that quote does not actually end this. So we can use the backslash, or I can actually use the single quotes here to avoid complaints like that. That way it's the same. So basically now we're going to iterate through this, and whenever it finds this, and there's a reason I'm doing this because I want you to see what's gonna happen here. It's going to keep going one at a time until it hits this, and then it's going to stop. And it's going to count how many words there are until that spot. It's going to print them along. So at the end, it's going to say stop at, and then W count. I put the str because otherwise it's going to yell at me because of concatenation, because it's a string versus an int. Okay, so it says stopped at 1. So you're like, huh? Wait, but this is not the first word. Well, yeah, but look at this. At the beginning, we also have this loop in here because we have the before loop as part of the code for this. You see that? So it's actually stopping at that one. So you're like, oh, okay, that makes sense. All right, well, let's try to maybe stop it somewhere else that has another thing that's not at the beginning. So let's do maybe like off, right? So there's an off in there. So if you run it again, this time it prints out every single line, one at a time. And it stops at the 18, which is near the end because the word off is almost right at the end. You see that? And so in this case, it actually matched it there. Or, you know, it could be a situation where, like, let's just put something that does not exist, and when it runs it, it's eventually going to hit the end, and then you're going to get an error that says list index out of range. What that means is that if you're trying to print out a list, but you go past it, so like, for example, in our index here, we have 6 things in there. So what happens if I try to, you know, you forget that this indexing starts from 0 and you're trying to print out the A and you end up writing data 6, which is actually not part of the list. That's what is known as an out of bounds error. Out of bounds errors are bad. You don't want them. They're not your friends. Out of bounds. What that means is you were trying to access an index that does not exist. In your computer, this is all stored in memory. And so what's kind of happening is you're trying to reach outside of that memory into somebody else's memory. So it's like, imagine that there's no fences between you and your neighbor, and you're planting a bunch of like flowers. And so you're planting tiny little squares that are like 1 feet by 1 feet. And then you're planting, and then you forget where the boundary between you and your neighbor is, and you plant one on the neighbors. And so now the neighbor comes home and like they're super like OCD about like where the boundary is, and then they see that, and then they go yell at you and complain to the HOA, and big argument happens, right? Because you went out of bounds. And the same thing with the computer. If you do that, you might get away with it. You might also, like, the moment you're about to plan it, your neighbor was like secretly watching you and comes out and like yells at you. Either way, it will not end good, because either the program will crash, you'll get an error like that will say you're out of bounds, or in some programming languages, it might let you do that, but like it's really bad because like it's not your memory. So like your neighbor could like be like, oh, it's my yard, I'm going to step on it. and kill the flower or something, and you wake up the next day and see it, and you're like, oh my gosh, what happened to the flower? Well, it was in my land, and technically they're right. They can do whatever they want with it, and so you have a problem, right? So it will never end well. So you don't want to do that. Like, good coach would never do that. And so if you ever get that error, now you know what it is. It's just going out of bounds, going outside of what you said. You could have always just said, I want more space in my list, or actually insert something valid there, and you wouldn't have this problem. But you know, that's just what it's trying to tell. Python's actually really cool about this errors, and it's very clear. Other languages, like C++. But yeah, so today I went ahead and I showed you basically how a list works in the most, so now we don't longer need to do this. We can just literally do a loop that prints out 100. But with the for loop, you'll see how this is really easy to do. So we are definitely going to pick this up next class and then expand upon this example that we were working on. We're going to come back to this example and make something with the for loop that's nicer. But at least we found a usage of the while loop for the example, which is to like look for a word if found. But we still have the issue of like this going out of bounds if it's not found. So we'll fix that with the for loop probably, or a way of knowing when we hit the end of the list so that we don't go past it. So, but at least now you have a basic idea of looping and more importantly of lists. So that next time when we really get into more looping stuff with the for loops and back to the while loops, then you will really get to sort of understand the power of what you can achieve between your list and your loops to make code that can really, really save you time. Because you don't have to write a lot of code, but the code can just run nonstop for a day and really do a lot of work while you're relaxing. And that's the end game, right? You want the program to work hard so you don't have to. So, yep, hopefully this gives you a nice little introduction into looping, and we will definitely pick this up next time. So thank you for watching, and I'll see you next time.